Hello, good morning, good lunchtime, good evening, wherever you are in this beautiful world. I greet you to our webinar on L4 autonomous driving. We are going to concentrate specifically today on regulation and standardization issues. My name is Axel Drecke. I am the chairman of the IEEE Industry Connection Group, nurturing the era of end-to-end mobility as a service. First, I would love to mention some housekeeping issues. This is a recorded session due to the global nature of our webinar, so all people are going to be muted. In case you do experience any problems in terms of the platform, please use the chat feature. And in case you want to forward any questions, please forward via the Q&A button. We will not be able to provide answers online, but I promise you we will come back to you with all the answers at the 18th of November when we are going to run our workshop, and this is going to be a live event. What is my job? My job is I am the chairman of the Industry Connection Group, IC 2009. You can see on the right my program committee. The idea is to speak about all kinds of hot potatoes in the automotive industry, specifically, of course, oriented around autonomous driving and standardization issues. I would love to get questions, whatever you like. Please come up with ideas. This is an open platform. Everyone can come up with ideas. Today, we are going to concentrate on regulation and standardization in preparation for our workshop on the 18th of November. We are going to hear first an update on UN ECE Regulations Work Project 29. This will be given by William Gauss, or Bill Gauss. He learned mechanical engineering at the Georgia Institute of Technology and is already a member of SAE since 1976. Since 2015, he is leading the ground vehicle activities of the SAE worldwide. Second will be John Tintinelli. John Tintinelli is at the SAE International, and he's going to give us an overview about the SAE standard activities. He's coming from the University of Michigan and is working with SAE International already since 2016. Last but not least, we will have an update of the IEEE activities in terms of standardization of L4. We are always talking L4. Hermann is an electric engineer. He concentrated in his studies on semiconductor issues in Graz in Austria. He worked specifically on ETSI and some other connectivity issues. And since 2017, he is leading the European activities of the IEEE. So let's go in. William, Bill, this is yours now.
Well, thank you, Alex, and thank you all for listening in today. I'm Bill Gauss, and I'm happy to be here. I'm coming to you as a spectator at the UN or a participant as an NGO, certainly with a front row seat involved in the regulatory activities, but I'm not representing the UN staff in this presentation. It's all my perspective and summary from SAE. I'm going to talk about WP1, Working Party 1, and also mostly WP29, but a little bit in WP1 as they're working on level 4 and automated driving activities. They've got 6 efforts listed here, And the reference document is the bottom of my slide there that spells out the details comprehensively. WP29, which is the World Forum for Harmonization of Vehicle Regulations, versus WP1, which is working on the driving and road traffic safety. There's two agreements, the 58 agreement, mutual recognition of type approval, and the 98 agreement, which are the global technical regulations, which include self-certification and type approval. Of note, what we're doing at the UN now in level 4 in automated driving is we're writing everything to be agnostic to both 58 and 98, and also any policy documents that any countries wish to adopt, such as the Amsterdam Agreement and such. Also mentioned that there's a 97 agreement under Working Party 29, which is the agreement on periodic technical inspections. We're not inspecting in vehicles in fleet yet, but I expect this to have documents in the future being worked on. WP29 is organized under what we call GRs, or Group de Rapporteurs, and there are three particularly ones that are focused on automated driving and level 4. The top one, GRVA, is probably got the preponderance of the work. And there's also work in the general safety provisions, GRSG, and signaling and lighting. I'm going to concentrate on GRVA today in my time. And these are the areas that have got work on. The top one is just a new initiative, artificial intelligence in the context of regulations. And that I expect will be brought across a lot of other GRs too. And there's cybersecurity and over-the-air updates. The safety of active safety systems, along with advanced driver assistance systems and automated vehicles. Two very large groups that are meeting regularly, validation methods for automated driving, called VMAD. I was working on new assessment and test methods, and I'm a co-secretariat of that, along with my colleague Oshida-san from JASIC. And then the functional requirements for automated vehicles, we call it FRAV. And then there's work at the event data recorder, the data storage system for automated driving, and that's done in conjunction with GRSG. Under FRAV, this is the scope. It's looking at the system safety, fail-safe response, a human-machine interface, operator information, and object event detection and response. And these are the current tasks. The timeline, we have an upcoming meeting in November where there'll be some informational updates, and March 2022 is a goal for the endorsement of the work. And the proposal they're working on of ADS safety requirements, that is due March 2022, or June 2022, excuse me. And the reference document below, which will explain what work is going on in more detail, is included at the bottom of the slide. So VMAD, these are the terms of reference, which I've just included for your information. I'm not going to read it. And the work that's been going on is a multi-pillar approach. It's scenarios, simulation, virtual testing, test track testing, on-road real-world testing, and an audit in-use reporting. And currently what's going on is the group's working on the second iteration of the WP29 guidelines, on the new assessment and test methods. We're calling this the master document. And we have some outstanding issues that we've been working on for several months, and some annex documents that will be included. The timeline, again, we're reporting in November at WP29. That's November 23 and 4 and 5. And then we'll have some endorsement in March 2022 for the NATM document, and everything will be complete, and including coordination with the FRAB requirements in June 2022 is the goal. And again, the reference document below. Regarding the event data recorder and data storage and for automated driving systems, DSSAD, we currently have event data recorders, but they weren't specified for recording particular parameters and time frames regarding automated driving. So this is being worked on and reviewed. Right now, there's an overall deadline of 2022, no interim no interim deadline specified. And the framework document for this is listed below. Cybersecurity and over-the-air software updates. The group is looking at a set of requirements under the 98 contracting parties agreement, and it'll have a report in a few weeks also at WP29 in Geneva, and the reference document is attached, is referenced below. A little overview, because I rattle on all the work. It's humbling. It's impressive how much work is going on in the scope of experts. We've got about 50 subgroups in automated driving, the working groups and informal working groups. Pretty much a meeting every single day, and the range is from 50 to 200 people on these WebExes, with about 60 member states, which are the contracting parties. And beyond the contracting parties are the standard development organizations like IEEE and SAE, consumer groups like FIA Foundation, the constructors, the suppliers, the software developers, technical services like TÜV and DEKRA, et cetera, and the road safety and transport research organizations. It's a very broad group of subject matter experts. It's fascinating to be involved in, and I encourage anybody with any interest to do so. And with that, I'll request you use the purple button. This happens to be the WP29 from June before the shutdown. We managed to get a photo in before things went south. So with that, Axel, I thank you for the opportunity.
I have to say a big thank you, Bill. I'm really impressed. And it looks like all activities are going to be publishing some results in November. So maybe we can present in November then already a little more. Thank you. So next is whatever is going on at SAE. John, the stage is yours.
Hello, everybody. I'm John Tintinelli. I'm the general manager for SAE in Europe. So this is a quick presentation of some of the overview of our activities that are related to level 4 automation. A little bit about SAE, because some people in this area, they only know us from, for example, J3016 and the levels of automation. We started as a very old organization at the beginning of automobiles itself. Henry Ford is one of our founders. And then adding aerospace to our domain as a standards development organization and engineering society by Wilbur Wright in 1916. Thereby sealing our role as the first and largest global mobility-focused standards development organization and technical society in the world. From standards and in those early days, we've of course matured, and we do all kinds of things now. Many of you have participated in some of our professional development. We do a lot of training worldwide for engineers to advance their education in very specific areas. We do a lot of charitable activities for youth and college students that are entering engineering. Of course, we have a membership organization, and we produce technical standards and a lot of publications. SAE itself, we're a small organization. We only have about 300 people working for the organization itself. What really is SAE is this global society of about 200,000 volunteers worldwide from just about every country you can imagine. And those people donate their time to help advance the knowledge of mobility engineering by contributing papers, by doing training, by participating in our charitable activities, producing papers, you sort of name it. And of course, in our standardization activities, some of which we'll talk about here. And very important that to recognize that global harmonization, especially in these areas of automated driving and now level 4 driving, is very important to us. And we work in cooperation with other SDOs, NGOs, and government organizations to achieve harmonization. SAE does not create standards. So SAE does not go out and say, hey, we're going to go do a standard on this and we're going to write it. Again, this is consensus driven. It's driven by people like you. Anybody can participate in an SAE committee and join standards if you're technically qualified. So the way it works is, people join committees or propose a topic. Committees then propose it. And government and industry can sometimes then get involved behind it to promote a standard. And then those are either voluntary or sometimes brought into regulation. A lot of our automated vehicle standards are organized according to a steering group, on-road automated driving steering committee, and there are a number of committees under that. We also have other committees that are tangential that produce standards related to level 4 driving. Again, our on-road automated driving committee standards, some of the stuff that we're doing right now, some of our works in progress. You can see here on this slide, there's of course some taxonomy documents which have been developed and are under revision. We've got some things related to validation and verification here, and testing and safe testing. We also have some things related to architecture, and also things for vulnerable road users and persons with disabilities. Key focus area for our standards in this area could be sort of, basically put into some of these other categories. So we obviously have things that are terms and definitions documents, such as J3016, which is our taxonomy definitions terms, otherwise known as our levels of automation. And then we have J3063, which is terms and definitions for active safety systems. We have things related to cybersecurity, so hardening of systems, and things that could fall into that were J3061, ISO SAE 21434, formerly J3061. It's sort of the next version of that in cooperation with ISO. We have things related to safety in general related to automated vehicles. Interoperability, obviously that's quite important when we talk about interoperability. We're talking about vehicle to vehicle, vehicle to infrastructure, in order to promote smooth transition through traffic. Then of course we have stuff with driver interfaces, other things related to vehicle performance, and testing. We have a specific committee focused on cooperative driving. And here you can see that we've divided some of that into some different task forces to focus on particular topics. And you can also see some of the specific works that we have here in progress. Going back to cooperative driving, one of the important documents for that has been released is J3216, which defines sort of cooperative driving levels, similar like we have automation levels. And for those, we have basically, several different classes. So class A is status sharing. So that's one vehicle, for example, communicates to another vehicle its position, maybe who it is, but not necessarily what it's going to be doing. Then you have class B, cooperation. So that's another vehicle sharing information about, and it could be with the infrastructure directly or with another vehicle directly, about what it intends to be doing. It might say, hey, I'm about to make a right turn here, or this is my end destination. And class C is agreement seeking. So that's, where we really get some cooperation. So that's when, for example, two vehicles share a common goal. So one vehicle might say, hey, listen, okay, I will stop here at this intersection and permit you to proceed through the intersection ahead of me as a goal. for safety and human factors related to connected vehicles and cooperative intelligence. Some of this has to do with messaging. We have the J2395 series, which defines some of these messaging priorities. Also, we have J2831. So that's about recommendations for alphanumeric messages within the vehicle. We have 2988, so that's regarding speech input and audible output for the vehicle interface. And then 2944, that's operation definitions of driving, and that's has to do with more performance measures. Again, for our hardening and cybersecurity activities that we're doing, I mentioned J3061 earlier and 21434. We also have some things specific to truck and bus. We have a steering committee just on truck and bus. J1139 is about hardening controls, communications within that heavy-duty vehicle network. And then for electrical systems, we have a work in progress, J2101. So that's protecting hardware security for ground vehicle applications. And then we also have, in addition to our normal standards, I think you've probably heard of our Automated Vehicle Safety Consortium. They've produced a number of documents out there. These are not necessarily consensus-based standards. This is a consortium group, but SAE does use these documents, and those get forwarded to the ORAD committee for further standardization activities. You can see sort of where SAE is going. We have a roadmap that you can see at sae.org/highlights/cav-source. So that website will provide you some more information on SAE's activities related to automated driving and sort of where we're heading. That's essentially our roadmap. So I encourage you to take a look at that. Please copy down that address and take a visit. And of course, for any other questions, you can contact me directly. Here's my email below. Happy to answer any questions or forward you to the right person, whether it's about level 4 standards activities or anything else. So thank you very much.
John, thank you very much. It's a pleasure, and it's really impressive how many people are working in the background on standardization issues to bring us all together. Because that's what I learned at my time at BMW. We can only survive by international cooperation. So next, last but not least, Herman Brandt with the IEEE overview. Herman, the stage is yours.
Thank you, Axel, and welcome everyone. Good morning, good evening, good afternoon, wherever you are. So my pleasure now is to introduce you, to give you an overview about standards activities for connected and automated vehicles in IEEE. And I'll start by giving a broader context about the digital transformation of transportation. Before I go into the details, please keep in mind that whatever I say, please regard it rather as personal views than the formal position or explanation or interpretation of the IEEE. Thank you for that. I'll start at the very high level of the IEEE, which is actually the world's largest technical professional organization. And you may have heard of our tagline, advancing technology for the benefit of humanity. I'm again and again impressed by the huge membership of more than 420,000 volunteers, engineers, experts from all over the world, from more than 160 countries. So from all the industrialized and world, of course, and all the emerging countries. And these experts are organized, they work together in technical societies. I will talk in a minute about what they all address. They also organize conferences, many in-person conferences, of course not in Corona times, and they publish more than 180 top-cited periodicals. So let's have a brief look at the technical societies and councils. So from an automotive, or let's say more general from a transportation point of view, you see there are two technical societies addressing transportation directly, like the intelligent transportation systems and the vehicular technology. But there are many ICT related activities which are foundational for the digital transformation of mobility, like circuits and systems, like computer, consumer electronic, electron devices, and so on and so forth. But I also wanted to mention these technical societies not only look at technical subject matters, but they also engage in education. They also look into social implications of technology. So, in particular, this one is very relevant also for coming up with relevant work when it's about trustworthy autonomous vehicles. And there is also one technical society dealing with technology and engineering management. So these technical societies, they not only publish and organize conferences and share scientific information about leading edge technologies and latest advancements, they also work together to look into the future, in future direction initiatives. And you see here the digital reality, for example, or transportation electrification or cybersecurity. On the other hand, they work together and engage in standardization. So they identify standardization needs. They leverage their expert knowledge to develop state-of-the-art standards. And not all of these technical societies are equally active in standardization, of course, but for example, the Computer Society, the VTS, the Vehicular Technology Society, Communication Society, Instrumentation and Measurement Society, they are really driving standards for the future of transportation. You see here on this slide, we have a sort of industry connections program where the more or less academic societies also reach out to the industry to better understand the needs of the industry. These industry connection programs often are pre-standardization activities. They organize webinars or workshops like this one. So, and actually the AV4M Mobility as a Service is the industry connection running the program. They organize, not only organize webinars and workshops, but also look in standardization landscaping and identify standardization needs. This is done, so setting up standardization project is done as a next step. And in IEEE, standardization projects are very much driven bottom up on a voluntary basis, market driven, but globally applicable. And we follow an open and transparent WTO principle compliant process to develop standards. Many of our standards are adopted by other standards developing organizations, including at the international level ISO and IEC. So for example, the software and system engineering standards, many of them are published or have the three logos at the cover page. But on the other hand, so of course, adoption by ISO, IEC, and also adopting ISO standards as European standards through the Vienna Agreement by SEN in Europe and so on. This is very much a mechanism to support regulation. On the other hand, it's always the manufacturer and the industry deciding which standards to implement in their product and which not. So could say the best standards users are their standards makers, but IEEE also provides services to support the implementation of standards, not only from IEEE, through testing, through open source development, and also through certification, also with third parties. Now, touching upon transportation. This slide shows the scope of our activities is really broad. So it not only deals with road transportation, but also airways and waterways and railways. And when it's railways, so railways are very much, so the hot topics currently are very much high-speed trains. And of course, the aim is also by doing that, by developing industry standards, further used by regulation, we are also aim to address societal challenges like zero accidents, zero emissions, no traffic jams, and inclusive mobility. The activities related to road transportation, they have been organized recently as a work program, which is called mobility practice. So by the way, in the IEEE Standards Association, we have several practices, also energy, also healthcare, and others. The mobility practice currently has 3 work streams. The first one about smart, safe, and trustworthy transportation. The second one about sustainable transportation. This is very much about electrification and charging infrastructure. The last one about mobility as a service and smart city traffic. Let's go to the next one to do a deeper dive into the first work stream. So trustworthy autonomous driving, and this is probably not new, it's common sense meanwhile in the industry. So, but still the challenges all relate to this transition from drivers to operators to passenger on the one hand, and from standalone cars to, in fact, end-to-end mobility systems, service offers rather than product offers, or a combination. And these new autonomous vehicles, they have to embed much more computerized intelligence, which means there will be much more microelectronics, more software, the automated driving systems instead of just assistance systems. And all of that imposes new safety risks and challenges for the self-certification or type approval, which in the future rather has to be a continuous process. And the safety problems are not only functional safety related, but include all the software, the data governance, and the software updates. The standards portfolio of IEEE since ICT, information and communication technologies, they drive the digital transformation of mobility. And ICT is part of the DNA of IEEE. So the internet is based on foundational standards from the IEEE. So there are many technologies in all our technical societies which actually offer solutions to industry challenges and have to be regarded as a basis to develop standards. And here you see some of the traditional competence areas of IEEE in the microelectronics and electronic design automation field. I already mentioned the software and systems engineering, the joint standards with ISO and IEC. You see here the example of life cycle management, process description, but of course this is a whole series of standards. Then testing and conformity assessment, including an automatic test markup language. Then in the middle column here in the slides, you see the whole stack from the Internet of Things to data information modeling and data governance to big data analytics and artificial intelligence. In particular, the connectivity part. So you see at the top, time-sensitive networking, the Ethernet, the Wi-Fi. So these are the physical layer standards. On top of those physical layer standards, there are edge cloud computing standards. And since more and more off-the-shelf computer platforms are used in networks, including the cellular networks, so there is more and more software-defined networking and network function virtualization going on and rolled out. And these are just examples of ongoing projects of the P1915X. X stands for several standards on security, performance, and reliability of software-defined networks. The instrumentation and measurement society has been instrumental for a long time already to develop standards for sensors and actuators. And this is, again, a foundational part of the Internet of Things. And emerging technologies like blockchain and mixed reality also open up new opportunities for the mobility industry. So, for example, mixed reality or the interoperability, real virtual world, and immersive user interface, one example, or blockchain to be used for in vehicles for smart contracts, enabling the various end-to-end services. Of course, all in all, and eventually this has to be, mobility has to be trustworthy. And meanwhile, this has many different flavors like safety, like identity management, like cryptography and cybersecurity, data privacy, and also includes unbiased algorithmic decision-making. The next slide highlights, the following slides, they highlight some recently kicked off activities. Recently means the last 1-2 years, because standards evolve rapidly in response to technical innovations. and technical innovations there are plenty of technical innovations in many of the technical societies. And of course, there are different standards may have different nature. There are functional and feature standards, like here indicated left bottom, related to technology enablers, sensor standards, then the positioning, navigation, communication, AI, and enabling technology feature standards. They may be relevant to be embedded in smart vehicles, but also in the intelligent infrastructure of road operators. So we have those two independent but cooperative components. Yeah, the vehicle architectures evolve because more and more communication mechanisms, ideally a multi-purpose communication backbone, has to be implemented in a vehicle. More and more sensors are added, more and more powerful computing elements are embedded. And last but not least, there have to be organizational and process standards for quality management. There are many already in place, but have to be expanded. On data-driven engineering for AI and scenario-based verification and validation. So this is quite new. And also the whole life cycle compliance, as mentioned earlier, is something to be addressed urgently. The next 3-4 slides are simply highlighting some IEEE standardization projects in this context, just explain. The first one being the time-sensitive networking. We think this will be the future in vehicle communication backbone, allowing to add more and more sensors for multi-purpose communication, not only infotainment, but also control information. Sensor work has been kicked off originally, and this is also, I want to highlight this a little bit because it's a good example. IEEE, I mentioned the ICT background of IEEE, of the electronic and electric engineers, and so all these huge expert communities. So they originally started to develop a standard for camera image quality and testing for smartphones. But then, of course, since cameras are more and more relevant also as an automotive sensor, they built upon this expertise and started to develop the camera image quality for the automotive imaging P2020 project. And well, they usually work closely with the AutoSense conference organizers and collocate meetings. And yeah, the first standard will be published soon. Then LiDAR standards, radar standards, and for radar standards, IEEE has a longer tradition for radars used in traffic speed measurements. Safety, as already said, eventually it's all about hitting the safety spot, and safety is one of the key components to build trust in autonomous vehicles. So there is the P2846 about assumptions for models in safety-related automated vehicle behavior, very much driven by VTS, the Vehicular Technology Society, and the Computer Society, and also the Reliable, Safe, Secure, and Time-Deterministic Intelligent Systems Technical Committee, Special Technical Committee of the Computer Society. The next example here, exchange interoperability format for safety analysis and safety verification of IP, SOC, and mixed signal. So this is really the chip level, embedding safety features into the chip design. And that's driven by our electronic design automation committee or council. And of course, there are more activities, as shown on this slide, about some AI activities used or relevant for AI engineering for automated driving, so object recognition and path planning. Then, so for example, here the P2834 on secure and trusted learning systems, distributed ledger technology in connected and autonomous vehicles, in-vehicle augmented reality. Of course, I also have to mention the IEEE 1609, the Family of Standards for Wireless Access in Vehicular Environments, so the V2X. There is the physical layer. There is an evolution of the original 11P. It's called the 11BD. Very much aligned also with so very much aligned is also in this context is also the certificate management system with the cellular V2X and also with the ECE ITS G5 standard. Yeah, there are, well, I also already mentioned verification and validation. So there is verification of autonomous systems, reliability, prediction of hardware, security requirements, and testing methods for operating systems in connected vehicles. So this one is really brand new. It's about to be kicked off in the near future. And with that, I wanted to say, and that's very important, so the IEEE Standards Association partners with a number of players, partly already indicated, to bring collective value. So because we recognize different expertise in different standards organizations, and we are convinced that no single standards organization has all the experts and all the knowledge to develop standards. And that's why we, on the one hand, work with ISO, IEC, partly to do joint development work with SAE in various contexts. Of course, IEEE as one of the standards providers for the internet, works closely with the IETF, with the Internet Protocol. We work with ECE in Europe, and and last but not least, we also have a service, the IEEE ISTO service, and ISTO stands for Industry Standards and Technology Committees. And these services, they support industry alliances, like, for example, the MIPI Alliance, which is increasingly also developing hardware interface standards for the automotive industry, the blockchain in Transport Alliance, and also a consortium for the landscaping of AI safety. And with that, I give the floor back to Axel. Thank you very much.
I like really how many people are involved in this international global standardization efforts, and even the big organizations are collaborating with one another, as I personally experienced the last weeks, because I'm involved with IEEE as well as SAE. Thank you very much. So I really have the pleasure now to, not hand over, but to invite you to our workshop, which is going to happen on the 18th of November 21, 8:30 European, Middle European time. We have really a full program, and the key issue is it's a hybrid event, so you can join online, and of course it will be recorded as well, so you can attend whenever you like. But the best may be to come up in person, join us in Munich at the TÜV Süd Training Center, which is in the West End Street 199. The registration page is given down there. There is going to be the agenda as well. So just click there. This is a registration for online as well as the in-person event. In case you will be, you want to join us in person, you will be asked by an email, are you going to come yourself, or are you preferring to be online with us? In spite of all the restrictions which are in the world still in terms of traveling, it's really great pleasure. IEEE is going to invite you for a cup of coffee, lunch, and even some drinks. Of course, in case you are going to come, please, 3G, according to German regulations, has to be applied. Means you must be healthy, recovered from COVID, or vaccinated or tested. After 30 years at BMW, a little more even, and 10 years doing free consulting, I really appreciate how global this world is. And I'm really, really proud of presenting this panel of really global presenters. We are going to have 16 presentations in 4 sessions. One session, the first session is update on standards. And here I promise you, whatever question you are going to come up with, it will be answered in the first session. Then we are going to have a session about enabling technologies, of course, LIDARs and all the sensing side, most impressive. And we are going to have a presentation about artificial intelligence as well. And last, but the third one will be a session about vehicle architectures. That's the field I'm coming from. Most impressive what is going to change there, as I just learned at the ELIF conference in Bonn last week. The last session will be about the approach on verification and validation. I don't want to give you all the names. We have 60 names, only to mention the keynote will be given by Alexander Kraus, who is the Chief Technology Officer of the Mobility Division of TÜV Süd. He's going to greet us there. And what I really like about Alex, he's really a promoter of global collaborations. We are going to have presentations from Europe, from United States, from China. I really would love to see you there. But there are further steps. We want to continue with this approach. We are doing this now since 1.5 years. We had a cybersecurity session. We are running this L4 event now. And please, whatever kind of ideas you have, and I have something in mind triggered by the presentations at the ELIF last week. But whatever you like to come on the table, to be discussed in public, our idea is always global. We believe in global cooperation worldwide. There's no use to do things not together or even against each other, only working global. The world will move on as fast as possible. Thank you very much. I hope you enjoyed our webinar and you could pick up some information. For me, I really have to say a big thank you to Bill, to John, and to Herman. I learned a lot about the regulations approach from the UN ECE as well as SAE and IEEE. And I know there are much more people involved in this. Thank you very much. Keep well wherever you are in this beautiful world. Goodbye. Thank you.